Assalamu alaikum dear students. Today we are going to discuss this exercise 7.1, how to find this indefinite integral of a given function by using this definition of indefinite integral, which is also called as the inspection method. So inspection method is actually using the definition of indefinite integral. The first example is, or the first question is, find the indefinite integral of sine 3x. Sine 3x. In definition of this indefinite integral, we consider a function. We have to find that function whose derivative is this function. So let us consider that function whose derivative contains at least this term, that is sine 3x, without constants. Like if we consider functions cos 3x, then differentiation of this cos 3x, that is d by dx of cos 3x, is minus 3 sine 3x. So by definition, indefinite integral of this function minus 3 sine 3x dx equals to cos 3x, or minus 3 is constant, so we can take it out from this integral sign, which implies that minus 3 integral of sine 3x dx equals to cos 3x, or simply integral of sine 3x dx equals to minus 1 upon 3 cos 3x plus c. So this means that indefinite integral of this function is minus 1 upon 3 cos 3x plus c. Now the second problem is e raised to power 2x. Now consider or think that function whose derivative contains this e raised to power 2x. So definitely that function is e raised to power 2x, because differentiation of e raised to power x is e raised to power x, which implies that differentiation of e raised to power 2x is 2 times e raised to power 2x, because firstly we have to differentiate the base, then the power. So derivative of this function, that is e raised to power 2x, contains e raised to power 2x without constants. So by definition we can say that this integral, by definition, integral of this function, that is 2e2x, equals to e raised to power 2x. Take 2 out, so simply we get e raised to power 2x is 1 upon 2 e raised to power 2x plus c. Third problem is ax plus b whole square. Now think that function whose derivative contains ax plus b square. So this means that we have to consider the function whose power or whose degree is greater than this 2 by 1, that is we have to consider ax plus b ka whole cube. So differentiating ax plus b whole cube, we simply get 3 ax plus b square into a. So here 3 is constant, a is constant. This means that by definition integral of this very quantity is ax plus b whole cube, or simply ax plus b whole square dx. Its integral is 1 upon 3 ax 1 upon 3a ax plus b ka whole cube plus c. This means that it is an indefinite integral of this very function. So from this we conclude that how to find without considering these two statements, or without considering this concept, that is to find the function whose derivative is this given function, what we do, we simply differentiate this, integrate this e raised to power 2 firstly, like in this example. Now we know that the integration of e raised to power x is e raised to power x, which implies that integration of e raised to power 2x is e raised to power 2x, like this very quantity. Then we have to differentiate this quantity, like 2x is here the power, so differentiate this power. Now the differentiation of 2x is 2, but write in denominator, because here we have 2. Like in this function, it is of the form of x raised to power n. So differentiation of x, integration of x raised to power n is x raised to power n plus 1 upon n plus 1. So this means that when we treat this ax plus b whole as this function, this means that its integration is x cube upon 3, that is ax plus b ka whole cube upon 3. Then we have to differentiate the base term. Here base term is ax plus b. its differentiation with respect to x is a. So simply write that quantity derivative of the base in the denominator, which is a. That is why we write simply ax plus b whole cube upon 3a. So this is the general procedure or shortcut method to find the indefinite integral by using the inspection method. Like if we consider two functions like this, e raised to power 2x plus sine 2x, its derivative is integral is given by breaking this integral, because we have finite functions, e raised to power 2 dx plus integral 2 sine x. Now integration of this e raised to power 2x is e raised to power 2x, then we have to differentiate this power and write this that derivative in the denominator, which is 2. Similarly, integration of this sine is cos, that is minus cos 2x, then differentiate the angle. Now differentiation of this angle is 2x, angle of this function is 2x, which implies that its derivative is 2. So write it in the denominator, we simply get minus cos 2x upon 2 plus c. So this is the required this integral of this very quantity. Like if we consider the polynomial, so x cube plus 4x square plus 9x plus 6. Now we can break this integral as x cube integral of 4x square, integral of 9x, integral of 6. Now here x cube, it is of the form of xn, so x 3 plus 1 upon 3 plus 1. Now 4 is constant, it comes out from this integral, we simply get 4 into x 2 plus 1 upon 2 plus 1. Similarly 9 is constant, it comes out, it is 9. Difference integration of x is x1 plus 1, because power of x is 1, that is why we write here x1, which is x1 plus 1 upon 1 plus 1. Now integration of constant with respect to x is constant multiplied by that variable, that is here x, it is 6x plus c, which is integrating constant. So simplifying this, we get x raised to power 4 upon 4, 4 by 3 x raised to power cube plus 9 by 2 x square plus 6x plus c. Now we have here the quotient function, x square plus 2x plus 3 upon under root of x. Here denominator is same, so we break this denominator or we distribute this denominator, we simply get x square upon x raised to power 1 by 2, because root means power 1 by 2. 2x upon x raised to power 1 by 2, 3 upon x raised to power 1 by 2. So simply we can write this as x square into, this term can be written as x square into x raised to power minus 1 by 2, because by shifting x raised to power 1 by 2 to the denominator, so its degree, its sign in the degree will change. Here it is plus 1 by 2, in numerator it will become minus 1 by 2. So we simply get x raised to power 2 minus 1 by 2 and plus 2x 1 minus 1 by 2 plus 3x raised to power minus 1 by 2 dx, which is x raised to power 5 by 2. By simplifying this power, 2 into x raised to power 3 by 2, 3 into x raised to power minus 1 by 2. Here we can use x raised to power n rule, which is x raised to n plus 1 upon n plus 1. So after using this and simplifying, we get 2 upon 7 x raised to power 7 by 2, 4 upon 5 x raised to power 5 by 2 plus 6 x raised to power 1 by 2 plus c, which is the required equation. Now third problem of this type is where we have this rational function x square minus 2x plus 1 upon x square plus 1. Sorry, it is plus here. X square plus 2x plus 1 upon x plus 1 dx. Here we cannot break the denominator, because denominator contains two terms. So if we break denominator, we will again we will not get this function in the standard form like x raised to power n form. So simply we will firstly divide this by long division method or by another method in which we get the division. How to get the division? So simply it is x square plus 2 plus 1, 2x plus 1. So this can be written as x plus 1 whole square upon x plus 1. So here numerator contains 2 factors, denominator contains 1, so 1 will cancel, we simply get x plus 1. Now difference integration of x and 1, it is x square upon 2 plus x plus c. This is required. Like if we have the product of two polynomials, which is product of two functions like root of x into 1 minus 2x. So simply root x means 1 by 2, multiplying this it is x raised to power 1 by 2 minus 2x 1 by 2 into x, which is x raised to power 1 by 2 and x raised to power 3 by 2. So using x raised to power n rule, we get 2 by 3 x raised to power 3 by 2 plus 5x 5 raised to power 5 by 2 plus c. Now the another question is, if a differentiation of f of x is x square plus 1 and f of 2 is 6, we have to find f of x. Now differentiation of f of x is here x square plus 1, which implies by this definition of indefinite integral or by inspection method, its integral, that is integral of x square plus 1 dx equals to f of x. Now its integration, that is x square plus 1 integration, is x cube upon 3 plus x plus c equals to f of x. Name it first. We have to determine f. But f of 2 is 6, which implies that substituting in this here, it is f of 2 equals to 2 raised to power 3 upon 3 plus 2 plus c, which is 6. Or simply c equals to 4 by 2. So substituting in this, f of x equals to x cube upon 3 plus x plus 4 by 3. So from this we conclude that this f of x, if the derivative of any function is known, and the value of the given function is also known, then we can determine this function. So this is used in to find the velocity if to find the distance if the velocity is given. So inshallah in tomorrow's video lecture we will discuss the another method of this integration. This was this inspection method or by the definition method of indefinite integral. From today's tomorrow we will discuss the few methods. So thank you.